Alright, hi everyone. This is the last lesson for your take-home unit, Unit 7, and it's also the most challenging lesson, so I really hope you have your headphones on. I hope you're listening really carefully because this lesson is really important and it's really hard. So let's go through this slowly and carefully. And remember to make any notes of any questions you might have that you want to email me for clarification, okay? So today we're going to talk about graphs of linear inequalities. So far we've talked about horizontal lines, vertical lines, slanted lines, absolute values, and step functions, but we haven't really talked about how to graph an inequality. So today your aim is that you can graph a linear inequality using shading, because there's shading involved, and solid and dotted line rules. So that's what we're going to work on today, and we're going to learn all about that. So we've graphed linear functions, and in the last lesson we learned that points that lie on a graph are simply the pairs that make the equation true, right? We did all that plugging in and found out if they were a point or not a point on the graph. So graphing inequality on the xy plane is exactly the same. To graph an inequality simply means to plot all the pairs that make the inequality true. Now what's weird about inequalities is that there isn't just one solution. An inequality has many XY pairs, which makes graphing an inequality a little bit different. When we graph a line, it also has a lot of XY pairs, but inequality has a lot more, and you'll see that when we take a look at exercise 1 here. So exercise 1 says, consider the inequality y is greater than x plus 3. The first part A, says, determine whether each of these points lie in the solution set. Sorry, I got a hair on my screen. So we've got 3 points. Let's see if they're part of the solution set. The last lesson we learned that all we have to do is plug these in. So I have y is greater than x plus 3. In this first example, I'm going to plug in 7 for y and 2 for x. When I simplify, I get 7 is greater than 5, and yes, that is true. So 2, 7 is a point on that graph. Let's do the next one. 0, 1. 0 is x, 1 is y. I'm going to plug it in the same way. Y is greater than x plus 3, but instead of y I have a 1, and instead of x I have a 0. Is 1 greater than 3? No. This is false, so this is not a point on the graph. And finally, the last one, 1 is x and 4 is y. So I'm going to have y greater than x plus 3, but instead of y, I'm going to try 4, and instead of x, I'm going to put in a 1. Is 4 greater than 4? No. It would have to also be equal to 4. So we've got some sample points, and we know that one of them is on there. So how can we graph the entire thing? Well, B now says, graph the line y equals x plus 3 on the grid below in dashed form. So there's something that we have to think about here, and I'm not sure how these questions lay it out, but when we have let me see here. So when we have something like this or this, when it's just greater than or less than, we have to make a dashed line, right? A dashed line looks like this, okay? So that's what this is asking us to do, to graph. So the original inequality is this: y is greater than x plus 3. To graph an inequality, you're going to graph it exactly the same way you'd graph a line, but instead of having an equal sign, you have this inequality sign. So this less than or greater than would be a dashed line. If we had a less than or equal to or greater than or equal to, then we'd graph it with a solid line. So these are 2 things that you have to memorize, the solid and dashed line rule. So we're going to graph this line exactly the same way we would normally. The y-intercept is at 3, so I'm going to make a point at 3 because of that 3 right here on the end. My slope, so let me write this out. My y-intercept is 3, and my slope in this equation is 1 over 1, right? There's an invisible 1 right here, so I'm basically going to go up 1. Let me write it over here so it's easier to see. My slope is 1, which is the same as writing 1 over 1, which is the same as going up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, and I'm going to make this line all the way across. Now when I connect them, I'm not going to connect them with a solid line. I'm going to connect it with dashes like this. Oh, my pen did a weird thing. right? I'm going to collect them with dashes. This is not happy about me making a dashed line on this screen. This is very strange. Sorry, I did not expect my pen to do this. Whenever I make a dashed line, it turns into select mode, and it gets kind of weird. There we go. So I've got my dashed line. So now the second question asks, why are the points that lie on this line not part of the solution set? Because it doesn't have this or equals to part. Because the inequality, the answer to this is because the less this greater than symbol does not include the equals part. If I go to this right here in my original problem here, that right there, there's no equals with it. So my points that lie along this line are not included in this set. Okay, so that's why if I go to the point right here, look at this point 1, 4. The point 1, 4, 1, 1, 1, 2, 3, 4 is right here, but this is not a solution. That's really important here, that any point that lies along the dotted line is not considered a solution. Okay, that leads us into part C, where it says plot the 3 points from part A and use them to help you shade the proper region of the plane that represents the solution set of this inequality. So I'm going to plot using the right colors. So the red point, okay, the red point is 2, 7. So I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7. So there's the red point. Okay, and that is a solution. The purple point is right here at 0, 1, and the green point is at 1, 4, which is right here. Okay, now notice the only one that was actually a solution was this red one, right? This was the only one that was actually a solution. These other two were not solutions. So the second part of something we have to think of, so this is really important, this green box here. This needs to be memorized here, the dotted and solid line. And the other thing we have to think about is our shading. Okay? So if I have a less than, equal to, or a less than sign, I'm going to shade either below it, below the line, shade below the line. And if I have a greater than, equal, or just a greater than, I'm going to shade above. So see how this red dot is part of the solution? Well, I'm going to shade everything above this line. Okay? Put arrows on the end. And this is my graph of y is greater than x plus 3. Okay? These are really important things we have to memorize, the dotted line and the shading. Otherwise, graphing an inequality is exactly the same. I still have slope, I still have y-intercept, but I have to remember whether I do a dashed line, a solid line, or whether I shade below or above. I'm shading above because this inequality says that I'm looking at all of the points greater than, right here, there's the greater than x plus 3. Well, here's the line x plus 3. I dotted it, and I want everything greater, so I'm shading everything above it. And that is why this red point right here that we found out earlier is part of the solution set. It's in the shaded area. So anything in the shaded area is considered a solution. So letter D now says choose a fourth point that lies in the region you shaded and show it's a solution. So let's pick any point in the shaded area. I'm going to pick this one right here. That's the point 1, 2, 3, 1, 2, 3. So negative 3, 3. And I'm going to prove that that is actually a point on the line y is greater than x plus 3. So let's plug it in. So instead of y, I'm going to have 3. Instead of x, I'm going to have negative 3. I'm going to simplify. Is 3 greater than negative 3 plus 3, 0? Yes, it is true. Any point I picked, I could have picked this point, I could have picked that, there, I could have picked any of these red points. They'd all be part of the solution set because it's in the shaded area. Okay? Very weird graphing, which is why I was saying this lesson's a little challenging. Okay, we're going to do some more practice with it here. Okay? So last part of this exercise says the point 10, 12 cannot be drawn on the graph above. So it's difficult to tell if it falls in the shaded region. Is 10, 12 part of the solution set of this inequality? If I were to like it said, I can't look at the graph, but what can I do if I can't look at the graph? What might I be able to do here? Well, I could plug this point in to the equation. So there are two ways to always find out if something's part of the graph. You can actually look on the graph, or you can plug it in. So I'm going to label this this 10 and this 12, x and y. I'm going to rewrite my equation. Y, same one, greater than x plus 3. But instead of y, I'm going to plug in 12. And instead of x, I'm going to plug in 10. I'm going to see if it will work. So simplify. Is 12 greater than 13? No, it's not. So my answer here is that 10, 12 is not part of the solution set. It would not fall on the shaded area. You have to keep in mind that even though this grid right here is only so big, this graph actually goes on infinitely, right? We can't graph the whole thing infinitely, but it does continue infinitely, all right? Remember to make note of any questions you have, please, and email me. You can also Google, guys, graphing linear inequalities, and you'll get tons of resources, other videos by other teachers giving more examples of this topic, okay? So if you Google this, graphing linear inequalities, you'll get a lot of information. All right, let's do another problem, some more practice here, at exercise 2. So there are some challenges to graphing linear inequalities, especially if the output y has not been solved for. We talked about this in a Do Now a couple days ago, actually, where we have to get it into the y equals mx plus b form. So this has to be in y equals mx plus b form to do anything with it. So letter A says, well, let's read exercise 2. Says, consider the inequality 3x minus 2y is greater than or equal to 2. Part A says, rearrange the left-hand side of this inequality using the commutative property of addition. So what it wants us to do is rearrange it, and this means that instead of saying 3x minus 2y is greater than or equal to 2, they want us to say, put the y first. So we're going to rearrange it and say negative 2y plus 3x is greater than or equal to 2. That is the commutative property of addition. I've just rearranged the two values. Okay? Now letter B says, solve this inequality for y. So I'm going to rewrite it. Negative 2y plus 3x is greater than or equal to 2. And I'm going to try and solve for y. So the first thing I'm going to do is subtract 3x, because I want to get y by itself. When I do this, these cancel out, and I'm left with negative 2y greater than or equal to negative 3x plus 2. So I can't combine the 2 and the negative 3x, so I'm just going to put them in order. So now I have to divide both sides by negative 2, and if I divide one side by negative 2, I divide everything by negative 2. Now here's where I have to remember something really important. When I divide by a negative in an inequality, I have to flip the inequality sign. So this becomes y less than or equal to 3 over 2x minus 1. Okay, really, really important that you remember when you multiply or divide by a negative, you must flip. Multiply or divide by a negative, you must flip the inequality. Okay, so now I've got this inequality right here, and I'm going to rewrite it on the left here. I've got y is less than or equal to 3 over 2x minus 1. Okay, that's my inequality that I have simplified from my original equation. All right. Now it wants me to graph the solution set onto the graph paper here. So I'm going to remember my rules here. I'm going to start graphing it like I would a normal line. So in a normal line, I would find my y-intercept. My y-intercept here is negative 1, so I'm going to go plot a negative 1 right here. My slope in this equation is 3 over 2, which means I'm going to go up 3 and over 2 when I start graphing. So I'm going to start here at this point. I'm going to go up 3. 1, 2, 3, and then over 2. 1, 2. And I have a second point. I'm going to do it again. Up 3, 1, 2, 3, over 2. And I have a third point. And then I have enough room on my graph to make another point down here. So I'm going to go down 3, 1, 2, 3, and over 2 this way. Now before I connect my dots, I have to think about, do I have to shade, do I have to make a dotted line or a solid line? Well, let's look at our original inequality. There's my inequality symbol, remembering that if, let me rewrite them down here, that if I have a less than or equal to or greater than or equal to, I make a solid line. If I have a less than or greater than without the equal to, that's where I make a dotted line. So this equation is going to be done with a solid line because I have this equals to underneath it, right? So I'm going to make a solid line connecting my dots. That's the first step. Now I have to think about my shading. So I have a solid line. And how am I going to shade? Am I going to shade above or below? Well, also remember that if you have a less than or equal to, you shade below. And if you have a greater than or equal to, you shade above. This is a less than sign, so I have to shade below. So I'm going to shade everything below this line because my inequality says less than. Okay? That's it. That's how I have to graph my inequality. So you better remember two things, the shading and how you make your line, solid or dotted. Okay? Finally, D says, pick a point in the shaded region and show that it's a solution to the original inequality. So I'm going to pick a point in the shaded region. I'm kind of out of colors here. Let's do red. So I'm going to pick a point. Let's just pick this point right here. It's in the shaded region, and this is the point 1, 2, 3, 1, 2. So this is the point 3, negative 2. So I'm picking the point 3, negative 2. And I have to show that it works in my original inequality. So the original inequality is this guy up here, that. So there's my original inequality, 3x minus 2y greater than or equal to 2. Okay? So I'm going to have 3 times, remember 3 is the x, negative 2 is my y. So I'll have 3 times 3 minus 2 times negative 2 greater than or equal to 2. And I'm going to see if this is true. 3 times 3 is 9. Negative 2 times negative 2 is a positive 4. 9 plus 4 is 13. Is 13 greater than 2? Yep, it does work. So it works algebraically and it works in my graph. Alright? This is probably the hardest type of problem you'll see because you had to do a lot here. You had to solve for y. You had to remember to flip your inequality sign when you had that negative. You then had to graph it like you would a normal line, except you had to remember to make it solid or dotted and whether you had to shade above or below. So it's kind of you're adding several things on to the original way you'd graph in Unit 6. Alright? Last exercise is graphing inequality that deals with a horizontal or vertical line. So exercise 3 says, shade the solution set for each of the following inequalities on the xy planes provided. First, state in your own words the pairs this inequality is describing. So, letter A says x is less than 4. In other words, this is saying that all of the points that are to the left of 4. Remember, a vertical line at 4 would look like this. So if I just have a vertical line at 4, it looks like this. However, this is a less than sign. So does this need to be solid or dotted? This needs to be a dotted line. So I'm going to make it a dotted line. And since this says less than, you're also thinking what numbers actually satisfy this. Numbers like 3, 2, 1, 0. So all of the numbers to the left of 4 satisfy this inequality, right? Numbers like 5 and 6, like this point 6, is 6 less than 4? No, that's why we don't shade it, right? So we're shading to the left. Letter B says y is greater than negative 2, so in our own words, we're saying all of the points above the line y equals -2. So we have the line y equals -2. It's going to be a solid line because I have this equals. So here's y is -2. And we want all of the points greater than y is -2, so I'm going to shade above. Okay? So another way you can think about this too is when you have less than or equal to, you can also think of it like shade above, or sorry, not shade above, but shade to the right. Oh my gosh, less than, shade to the left. And if you have greater than or equal to, it's kind of like shading to the right. Okay, when you're thinking about a vertical line. Okay, again, this is a really tough lesson. I encourage you to look online for more examples if you need them, and really take your fluency seriously, not just copy it, but experiment and try and see where you're getting confused, because there's always questions like this on the Regents. I've seen it almost every year. And this is pretty easy. If you can graph it on your calculator and all you have to remember is your dotted and solid lines and your shading, this should be easy points for you guys to get. So please email me, reach out if you need help. This is your last lesson for the take-home unit. I'm really proud of you guys for working at home and getting your grades caught up. I'm really happy if you're working already on it. Good luck, and please reach out.